this is the solution to specimen paper, section 8, question 4. This time I'm going to talk through the written solution that you get on Moodle. So the question is to find the equation of the tangent to the curve x squared minus 2xy plus y squared is 31, and we want the tangent at a particular point when x is 2 and y is minus 3. Well, what I notice here is I want the equation of a tangent. So I'm thinking the equation of a tangent is a straight line. So I'm going to be using the equation y equals mx plus c, or y minus y1 equals m into x minus x1. Well, of course, I already know a point on the line because we're given that x is 2 and y is minus 3. So I know y1, 3, I know x1, minus 3, sorry, and x1 is 2. So the thing I need is a gradient. And of course, the gradient is given by dy by dx, so I need to find dy by dx for the function that we are given. Now, unfortunately, this function is not given explicitly y in terms of x. It's given as an implicit equation. So therefore, I need to do implicit differentiation to find an expression for the gradient. So what this means is to differentiate this implicit equation, we're going to differentiate each term in the expression separately. Hence, the first line of the solution, we need to differentiate x squared with respect to x, differentiate 3xy with respect to x, etc. So if I differentiate x squared with respect to x, that's okay, that's just 2x. If I differentiate y squared with respect to x, then I get 2y dy by dx. And the reason why we add the dy by dx on is because we're differentiating y with respect to x, and hence we are using the chain rule. If we differentiate a constant with respect to x, then that will be 0. So if we focus now on how we differentiate 3xy with respect to x, I'll just put a little bit more detail for that one. I want to differentiate 3xy with respect to x. Well, I'm going to have to use the product rule here. So I'm going to let 3x equal u and y equal v. So I'm going to be using the product rule, which tells me that dy by dx is u dv by dx plus v du by dx. U is equal to 3x, so du by dx is 3. V is equal to y. dv by dx is just going to be 1 times dy by dx. So now I'm ready to substitute into this equation. So I can say it's u times dv by dx plus vy multiplied by du by dx, which is 3. Hence, the expression which we put in brackets in the solution, just to make it clear that that was the differential of 3xy. The brackets are useful because we've got a minus sign outside. I want an expression for dy by dx, so I'm looking to take out dy by dx as a common factor. So what I'm doing here is putting the terms that do not involve dy by dx together, and the terms which do involve dy by dx together. I then take the dy by dx terms to the other side. And take out dy by dx as a common factor. Now divide both sides by 3x minus 2y, and we have our expression for dy by dx. Okay, then we just substitute x equals 2 and y equals minus 3 to obtain dy by dx, which is the gradient at the point where x equals 2 is 13 over 12. Hence, the equation of the tangent, y minus minus 3, y plus 3 equals m, 13 over 12, x minus 2. Multiply both sides by 12, multiply out the bracket, rearrange, and we find that this is answer A. I would say that question 4 would be one of the more difficult questions in section A, not because it's conceptually difficult, but because there's a lot of work to do and it's very easy to make careless mistakes.